right, I'm back. And so what we want to have is a connector between r and theta, a connector between v, which is speed, and omega, which is rotational speed, and we want to have a connector between linear acceleration and rotational acceleration. So if somehow you can figure out these quantities over here, you will automatically be able to figure out these quantities over here. Okay, so in order to understand this, let's take out our wheel once again, and I'm going to set up the wheel here. It's a shame that the wheel is black. Okay, it would be nice if it had reflectors on it, but it doesn't. So I'm putting the two prongs up here at the top, okay, so that you can see where it begins at. Can you see me? All right, I hope so. And what we're going to do is we're going to rotate the wheel. Now, I don't really have enough room to be able to rotate this thing properly. So you could use a pencil, you could use a can of spray paint, you could use anything that is circular to do this demonstration. And so on the ground, I'd like for you to put a measuring tape. Okay, so you're going to take a measuring tape, put that on the ground with the 0 point down here. Okay, so the 0 point is going to be down here, and then stretch it out on the floor. And then what I want you to do is to roll this thing without slipping and make it go around in a complete circle. And then I want you to measure how far that is. Okay, so the wheel is going to go around one complete revolution, and then what I want you to do is to measure how far did it travel sideways. And you want to do that in meters. So do it in centimeters, then convert it to meters. Okay? So what's then going to be the connection between how far did it roll sideways versus how far did it roll rotationally? Okay? So it's going to be related by the radius of the wheel. So you could do another experiment if you wanted to. So this time, instead of this big wheel, take this thing, put it on the floor next to your ruler, and very carefully make this thing go around in a complete circle and measure the distance it travels sideways. So the distance it travels sideways is going to be the letter R. The distance it rotates, so it's going to be one complete rotation, is going to be theta. So that's rotational distance. It's the angle through which the tire rotates. So the connector between the two is going to be the radius. So did you notice that when you did it with this thing, it didn't travel very far? But when you do it with this thing, it does travel a long distance sideways, because this has a bigger radius than what this thing does. So we're going to symbolize the radius with a capital letter R. So that linear distance is a little r, and then the radius of something that's circular is going to be capital R. So our formula is going to be, now it's kind of unfortunate that I've got these things flip-flopped here, but well, I can put it over here. All right, so R on this side is going to be equal to capital R and then theta. So that we've got the rotational stuff over here, we've got the linear stuff over here, and then the connector between the two concepts is going to be the radius of the thing. Now this only works if it's rolling without slipping. All right, now the next one we want to consider is the speed at which the tire is moving sideways versus the speed at which the tire is rotating. And again, no slippage. So it's going to roll on the ground without slipping, and the connector is going to be the radius again. So over here, you're going to have linear speed, and then over here, you're going to have angular speed, rotational speed, and then the connector between the two concepts is going to be the radius again. And we could even do it for acceleration, but we're not going to. So you notice it doesn't have a red box around it. So the last one is the relationship between the linear acceleration A and then the rotational acceleration alpha, and then the connector between the two is going to be the radius. So let's try it. You have a tire that is 0.35 meters in radius. It rolls without slipping 3 times. How far did it travel in meters? So let's write down what we're given and what we're looking for. We know the radius, and radius is given by capital R. So the radius is going to be 0.35 meters. Okay, now the next thing is, what was the angle through which the tire rotated? So it said it rolled without slipping 3 times. So that's going to be 3 rotations, but remember, that's the wrong unit. The correct unit for angle is the radian up here. So we're going to do that thing where we have the 2 parentheses and we're going to convert from rotations to radians, and it turns out to be 18.84 radians. Okay, now we want to find the linear distance it traveled. So we're trying to find R in meters. Okay, so now we'll go back to our formula that connects everything, so that the linear distance R is going to be equal to the radius of the tire multiplied by the angle through which it rotates through. And so that's going to be 6.59 meters. So that would be an example of how to use the formula. And then let's take a look at this one. If the tire in the previous problem is traveling at 5 meters per second, so that's a linear concept, so we know the V, 5 meters per second, then what was its rotational speed? Okay, so this time we're going to know this thing, and we need to find this thing over here. We need to find the rotational speed. Okay, so we're given the linear speed is 5 meters per second. We know that the radius is 0.35 because it was the previous problem. We're trying to find the omega. So we're going to find the equation that connects the letters. So in this case, it's going to be this one here. And then we're going to plug in our numbers, solve it, and it turns out that omega is going to be 14.3 radians per second. And then if you wanted to, you can convert it from radians per second into revolutions per minute, RPMs. We're not going to do that, but you could do it if you wanted to. All right, so this is a pretty important concept. All right, let's take a break. When we come back, we're going to talk about a special kind of rotational acceleration.